So good afternoon, everybody. My name is Matthew Rhodes. I'm the project lead for the Indus project, which is a discovery phase project, as we all are, I think, this afternoon, sponsored by UKPN. There are 5 partners in the project, in addition to UKPM, Cameros, which is my company, M3 Mass, Amoresco, Peterborough City Council, and Guidehouse. And this afternoon's presentation will be delivered by me, Lucas Duvaris, who's the innovation lead from UK Power Networks, and Hannah Swinburne from Peterborough City Council. She's the lead principal climate change officer. And we're hoping she's going to join us, but she wasn't actually here a second ago. We'll see when we get there. Move on to the next slide, please. So the focus of our project is within the overall space of decarbonising heat and accelerating decarbonisation of heat. We're looking very specifically at industrial heat demand, and specifically within industrial heat demand at dispersed or distributed industrial sites across the UK, across the UKPN's licence area, specifically for this project. The rationale for that, as Manu actually intimated in his introduction, there's been an awful lot of policy attention and funding on the kind of 2 extremes of the industrial sector in the UK, which is the one end, the heavy industrial sites like steelworks and petrochemicals. If you look at that left-hand chart, the ones where the energy intensity is well over 40 terajoules per £1 million of output. And there's also been a tremendous amount of attention paid to buildings, as we all know, which is, includes office blocks and covers the people at the top of that chart. So, and off it, but theatres, entertainment, hospitality, and general office buildings. But there's a whole space in the middle, which consists of manufacturing businesses, people like hotels and accommodation as well, but waste sectors, metal processing, which has been missed out. And typically we're talking here about relatively small operations, probably 10 to 50 people spread out across the country, and they account for 56%, as the chart on the right shows, of UK industrial energy demand, or industrial carbon emissions. And that is then 17% of total UK energy demand. So we're focused really on that 10%, so half of 17%, or just over half of 17%, and how you do that. This is important to the electricity networks for 2 reasons. One is, as mentioned on the slide, that decarbonisation means switching off the gas and switching to electricity. So greater demand for electricity. How do we meet that? Are the networks strong enough? But also for this demographic, there are spatial consequences, because unlike steelworks or petrochemical plants, it's likely that as we decarbonise the economy, these types of operations might well move to where they can access lower carbon infrastructure. So there's a significant spatial dimension, apologies, a specific spatial dimension to the problem here, which of course is relevant to network operations. So we need to really, as networks, it's really important, the infrastructure networks, understand this demand, understand how it's likely to change over the next 20 or 30 years, and understand the nature of that change, not just in terms of magnitude and when, but where as well. So that's the basic problem we're trying to address. If we move on to the next slide. Yeah, so I'll hand over to Lucas now to give UKPN's perspective on this problem.
Thank you, Matthew. So I think Matthew pretty much covered what are the challenges from a network perspective. If you have all the sites decarbonizing in isolation, then this is going to have a huge impact to all the networks overall. And as a network, we are trying to be key enablers in the energy transition and not blockers. We don't want to say no to customers when they are asking for some capacity for a new development or for an upgrade in the existing development. So Matthew is going to talk to you about the Indus solution in a bit. Just at high level, it's going to be a solution that will be an offering from UKPN to industrial customers and developers to offer a path to decarbonization. But at the same time, it will be something that we're going to incorporate in our processes internally. So where we identify that there is a requirement for an industrial solution that will be more coordinated because of the Indus solution that we're suggesting here, then the investment needs will also be incorporated in the planning processes, and we'll know how to deal with the increased demand over the next few years. So as you understand there, we're talking about a product that will involve multiple parties. So it's not only the DNO that we need to understand the process, but we also need to understand what are the requirements and needs from industrial customers and industrial developers. We also need to understand what are the challenges from the local authorities perspective. And we are trying to get all the people involved in such solution in the project in the alpha phase to have a holistic approach. So that was from me. I will pass over now to Matthew because I believe that Hannah had some issues with connection.
So if we move on to the next slide, yes, I think it's probably Hannah trying to call me a minute ago to say that she was having issues. So we've been doing this project focusing on Peterborough, Peterborough City Council as a local authority area, because as I'm going to explain in a moment, the strategy is to try and actually do one of these developments in a very specific place. So it's very important we engage with the local authority. Peterborough, a really good choice because they have declared a climate emergency. They've gone quite a long way down the kind of energy road in terms of a local authority understanding the issues. They've got their own solar farms and so on. So they're very into this agenda in general. They're also a growing economy with space to grow with some fairly meaty industrial activities. So there's a domestic appliances factory, Whirlpool, and Perkins Engines, well established in Peterborough, and lots of growing industrial activity. So we've worked very closely with Peterborough throughout the project, and they're very, very supportive and enthusiastic about it. It's a pity Hannah can't be here to say that herself, but she would have said something along those lines. So let's go on to the next slide. Okay, so I'm now going to give you an overview of what we've actually got up to in the project and where we've got to and where the next steps are and how we hope to take it forward into alpha. So if we go on to the next slide. So we presented the problem in terms of a high-level challenge of decarbonising this particular demographic, these dispersed industrial sites across the licence area, and there are tens to hundreds of thousands of those across the country. The core hypothesis of Indus is that decarbonising those sites where they are is probably not the lowest cost solution for network customers. So basically, you'd have to invest considerably in the network to decarbonise them where they are. If you group them together in clusters, it will cost less because you'll be able to optimise the infrastructure more easily. But that creates a whole range of new challenges. So what we've tried to do in this discovery phase of the project is really answer two questions. Firstly, is that hypothesis correct? So are there benefits from doing this? Intuitively, there should be, but are there actually, can we identify those and can we quantify them? And secondly, if there are those benefits there, how can the network, the electricity network organisations in particular, make sure, as Lucas intimated, that they are supporting a process of making this happen, the lowest cost approach to industrial decarbonisation, rather than being a barrier. So that's the kind of two core things we were looking for in the discovery phase. We've gone to the next slide. Okay, so we had 5 work streams. The overall project strategy has been from the beginning to try and do this. So we learn by doing. What we're trying to do is actually cluster a bunch of industry together, identify the infrastructure it would need to be net zero, work out how the network can support that. And by seeing how replicable that is, we can quantify the benefits and so on. So that's how we're going to answer the problem. Those were the 5 work packages. We go on, I'll talk a bit more about what we did in work packages, which is more interesting. Okay, next slide, please. So every work package has contributed. It's been a really good project, interesting relationships and very constructive work between the 5 partners and UKPN. What this slide shows is some of the outputs of those work packages. So top center, you can see an industrial park. Just if you had any uncertainty about the kind of thing we're looking at those, and we're looking at how we develop those over the next 30 years for a net zero world and how the networks support that. On the left, you've got some work we did on how many of those are there, where is the best place to put them, where is industry at the moment. So we've got quite a lot of GIS mapping activity within the project where we've identified different types of industry, energy demand profiles and so on, all helpful to give DNOs a sense of where this problem is and where it might move to. So the spatial type work, and we've identified we think over the next 30 years between 67 and 250 odd locations where these kind of parks will potentially develop in UKPN's license area. Over to the right then is some of the work done by Amoresco, looking at, given that this is what you're doing, what is the kind of infrastructure that would be deliver net zero on these sites? And they've come up with 7 generic types of infrastructure solution for the parks. And then at the bottom, moving towards the kind of benefits case and the how are we actually going to make this happen? That's a piece of work, really quite interesting piece of work that Guidehouse have done on all the potential regulatory barriers and mechanisms that might exist within the energy sector that might potentially inhibit getting there, so that we understand where they are. Positive outcome of that piece of work was it's far less challenging than, so that the environment's more receptive to this approach than we thought it might be. Okay, if we go on to the next slide then, and then which is one of the more exciting slides, if you like, because this is the answer to the first question I put: is the hypothesis correct? The answer is yes, the hypothesis is correct. If you cluster these sites together and find a way of doing that and provide the infrastructure support them, we've identified an estimated £155 million of benefits to network customers from avoided reinforcement costs by clustering together industrial sites in the kind of way we're looking to do. So 33 million within UKPN's license area, and you can extrapolate that across the country. We've profiled it to 2050 using some of the various scenarios that are out there. And it's important to stress this is a first cut conservative figure. So we're looking only at avoided reinforcement costs, and bottom left there you can see a range of additional benefits that may well accrue, particularly on the customer side. So customers benefit from this themselves. They make their own savings that the energy system doesn't see. So we think we can get more, but we've got a good starting point. Okay, if we just move on to the next slide. The discovery paper has been really helpful to this project, and we've moved quite a long way without actually changing the core of what we're trying to do. So we're trying through the whole SIF process, if we can get to the alpha and beta stages, to actually intervene in one of these industrial developments. Sorry, that's me reminding me of the 15 minutes. To intervene in one of these developments and make sure and implement the solution we're developing. I think if I kind of jump to the middle of that slide, one of the things we've learned during discovery is how challenging the commercial development world is, or not challenging, but just complex, and getting into that at the right time in the right place is something which is very difficult to engineer sometimes, because there's a lot of game playing goes on actually there. Local authorities are really important. Economic development agencies are really important because they control the big picture here, the spatial planning, where people are likely to locate their industrial plants, and they can influence that to some extent. But the big lesson is the power here of the DNO, if they are able to kind of come into this market with a solution that is particularly designed for this kind of collaborative industrial decarbonisation. So the big difference between the Indus type approach and the business as usual is the business as usual is all framed around individual customers, individual industrial entities approaching DNOs for connections or enhanced capacity or whatever. And it gets in the way of those companies collaborating with their neighbours to come up with a lower cost way of decarbonising, or a faster way of decarbonising, or a more efficient way of decarbonising, particularly from the infrastructure provider's perspective. And they're never going to lead that kind of solution because it's too difficult for them, let alone dealing with a DNO that only deals with individual customers. So there's a real opportunity here for DNOs to go into that market and say, we actually have a solution. If you're prepared to do A, B, and C, then we can do D, and the whole of that will save everyone money. So that's a really powerful thing, and we're going to build our alpha phase proposal very much around that, and then test it on the specific development we're hoping to identify in Peterborough or the wider UKPN license area. We also learned quite a lot about data, of which there is a lot. Organising it in a way that's meaningful to planning and identifying these sites and all the rest of it is quite a big task. We think there's serious value in developing a methodology that could be applied across all DNOs to understand industrial energy demand and identify sensible solutions for that. So that's the final lesson. And I think if we move on to the next slide, my final one. So in the alpha phase, we're applying those lessons. As I say, we're building it around work package 2, which is developing a DNO solution for Indus type industrial parks. And Amoresco, then work package 1, will be working through an investment case for one of the industrial parks we'll be working with, or the industrial park we'll hope to work with in the beta phase. And we've already got a short list of about 10. The other work packages all support that and make sure we go to market with a sensible product. Thank you.
Great. Thank you so much, Lucas and Matthew. So I think we'll go into the Q&A. So I think I'll start off with there's a question from the audience, from Maxine, a really interesting one, which is kind of going around my head as well, which is, would there be scope at some point to also look at implications for gas networks? So rather than just kind of power networks coming forward with a solution, is there some integrated approach where gas and power networks comes together? And I think she's just made a note also that that's perhaps useful for industries, but also as gas networks are figuring out their, I guess, future role in a system transition, that also might be a more coordinated way to kind of think of their role. Like, yeah, have you guys given any thought to that?
Yes, shall I answer, Lucas, and you can maybe come in and add anything to it. Absolutely, we have. I'm pleased to say that Cadent Gas have agreed to join the bid for the alpha stage, so that we can build that into our approach. There's clear interactions, because some of these companies need gas and they can't be decarbonised by electrification. That was a simplifying assumption that was floating around in the policy world for quite a long time, which was basically the only people it's difficult to decarbonise from difficult to electrify are steelworks who need a bit of coke and petrochemicals and so on. But actually there are chemicals plants that are quite small, aluminium foundries and brickworks and people like that who need gas. So they can't electrify. They do need hydrogen. You then have a question how you get hydrogen to those sites. You can ship it into those sites. You could also generate green hydrogen on site, which would mean electrolysis, which means electricity again. So, you know, there's very, very clear interaction. It's a really good question.
Thanks, Matthew. Lucas, do you have anything to add?
No, I think that Matthew covered it pretty much. We would like to work with Gas Network because of the experience that they have in the sector. And we're actually, as I mentioned in the beginning, we're trying to engage with all the different players that are involved in this kind of solutions. That's why engaging with a gas network, it's really vital for the project, because some of the solutions will involve gas as well. Some of the future solutions will involve gas. I'm talking about the solutions that were developed in the pattern book that Matthew showed really briefly before, but all can be found in the deliverables and the end of phase report as well.
Thanks, Lucas. So we've got a couple more questions. One from Ben, which is, I guess, a more kind of analytical question, which is, could you maybe give a little bit more information on how the energy needs were assessed to, when you then look at the infrastructure opportunity or the decarbonization configuration opportunity? Did you do like a different profile of industrial commercial sites and then you built them up? Was that kind of how the analysis was done?
Yes. So yeah, so we have data by SIC code. So we have standard data sets for the split of industrial demand by SIC code. So for example, if you take I don't know, a steelworks or a manufacturing of, it would be manufacturing of cast metal products or something like that. we have data which shows how much energy in that sector is spent on buildings, how much is spent on high temperature processes, how much is spent on low temperature processes, etc. So we have characteristics by SIC code. Interesting aside, in fact, on one of the early slides, in these kind of businesses, 90% of the energy is process energy, not building energy. So just kind of reinforcing my early point that solving buildings does not solve industrial energy demand. So that's the short answer is yes, and we did it in the way I've just described. That is a very kind of statistical way of doing it. We blend that with a bottom-up way, so we use that to identify kind of high-level potential for Indus type solutions or locations and bringing people together, or the right kind of people together. But the actual methodology, if you like, requires the engineering team, in our case Amoresco in this project, to look at the actual energy demand. You've got to get into the detail of the individual operations of the individual companies in the actual industrial parks to optimize anything from a network perspective or from an industrial park perspective. And we're trying to generate, I guess, a solution or an approach that can accommodate that need for very specific local solutions without making the solution so complex no one can use it. So there's a path to be trodden.
Thank you so much. So I think Ben says it's very applicable, and he's going to reach out to you regarding another project. So that's great, and that's exactly what these sessions are for. That's great. I think just an observation from Rob rather than a question, that I guess kind of energy as a service type offering is a really interesting attraction to industrial parks, but that's generally the reason they're kind of situated somewhere, because it gives you access to kind of critical assets or services. So this is a really nice proposition. So I think that's just a comment. Just one, I had a couple of questions. Actually, on the commercial side, I'm really interested. Like, I mean, Matthew or Lucas, do you see essentially that there's like a special purpose vehicle or something similar that sits on top of these parks, that then there's kind of a single legal entity that then engages with networks, for example? Is that kind of how it might potentially work, rather than so many individual entities?
Yes, is the again the short answer. It might work that way. I think it's about kind of facilitating the path to that kind of outcome, that kind of commercial outcome, and making that the natural way of developing these kind of parks. Because without, I mean, like many things actually, in my experience in the energy system, or the UK energy system anyway, almost anything is actually possible, including probably very flexible industrial park developments with optimized infrastructure. So it's theoretically possible from an engineering and a commercial perspective, but practically it's virtually impossible to make happen because the business models of all the participants, and including the DNO and probably the gas networks as well, make it very, very difficult for those outcomes to occur. So one way of looking at Indus is really making it much easier for people to set up those kind of vehicles, because it simply becomes naturally the sensible thing to do when you want to develop an industrial complex in the UK.
Thanks, Matthew. I mean, one question to Lucas. There's always this kind of chicken and egg situation, especially on sectors that are still figuring out their decarbonization trajectories, in terms of, will they figure it out and then the infrastructure will come, or do you make strategic infrastructure choices and then they'll figure out how to decarbonize? Like, does this approach start to help you kind of break that cycle a little bit? Is that, do the networks now think of a configuration, or is there a way of this industry is working through this and then a more coordinated approach to infrastructure development happens? Like, does it kind of help break the cycle a little bit?
I think you're right. So a reason why we are actually dealing with this project at this point is because we are trying to influence the decision making when it comes to industrial decarbonization in a good way, of course, that is applicable not only for the industrial customers and cost effective for them, but also for the DNOs. because it will also help us to identify where you need to invest in the future, instead of just a customer coming to us and letting us know that they need a really high capacity for the next couple of years. So we are trying, as I said in the beginning, to be key enablers in energy transition. That's why an Indus solution, even though the decarbonization of the industry, I don't think it's something that we'll see a lot in ED2, is actually having the tools in place prepare us for ED3 onwards. So this is how we actually see it, and also maybe also transform the business internally and how we work, because as of the 1st of April, we have established a DSO, which is a different entity. And for example, within a DSO, we have a new team that is focusing on local authorities and how you can help them decarbonize. So why not develop something similar for industrial users in ED3, for example? So this is another idea that we might have for the solution in the future.